graph of a rational function. Now we're going to talk about graphing rational functions. In the last section, properties of rational functions, we talked about most of these components here. So now what we're going to do is we're going to kind of put them all together so that we can actually create a complete graph. So the first step here says, find the Y-intercept. So that's what we're going to do first. So the Y-intercept is where my x is 0. So I have a function down below here. And we're just going to run through all of these steps so that we can actually graph this function. Okay, so first off, we need Y-intercepts. So let's go to this section, go to the next page here and figure out what that means. So if it's a Y-intercept, let me put step 1 here. That means my x is 0. So then for y, or z here, zx, it's still my y though. And that's going to be 2 squared times -5 all over -3, 1, and 4. So all I did here was plug in 0 for x. So that's going to be a 0, that's going to be a 0, that's going to be a 0, 0, and 0. And that's what we see down below here. Just kind of taking all those out. So this is really going to be 4 times -5. So that's -20. And then down below I have 1 times 4, which is 4, times -3 is -12. So that's going to be 5/3. So my y is 5/3. So my y-intercept is 0, 5/3. So I'm going to erase this information here because we're going to need some space for this. So step 1 is the y-intercept. And this, I'm actually going to put over here. There we go. And then step 2, let's find out what that is now. Factor the numerator and the denominator. Okay, that's already done for us for this problem, so I'm just going to put a check mark, just say we did it already. Step 3 says for the factors in the numerator, not common to the denominator, determine where each function in the numerator is 0. So we need to find the x-intercepts. So I did the y-intercepts, and step 3 is find the x-intercepts. And to find the x-intercept is where my y value is 0. So that means this whole thing equals 0. Now think of this here. If I pick a number, let's say -2, I see that this piece is going to be 0. Now this would not be 0, that would not be 0, and that would not be 0. That would just be some finite number for the whole bottom once I times them all together. But here I'm going to have 0, and 0 squared is 0. And times another number is 0. So 0 over another number is 0. So what happens here is all we have to do once it's in simplified form or reduced form, which means I can't cancel anything out top and bottom, then I can say that all I really have to be concerned about is where the top is 0. And I can see that happens where x is -2 or +5. So the ordered pairs then are going to be -2, 0. Let me fix my 0 there. And 5, 0. So those are my 2 x-intercepts. So now that's step 3. Let's take a look at step 4 now. Step 4 says find the multiplicities of the x-intercepts to determine the behavior of the graph at most points. Okay, at those points. So when I look at 4 here, my zeros are -2, 0 and 5, 0. And if I look at 5, 0, notice my degree is odd here, and it's a 1 there. So 5 is a 0 of multiplicity 1, And negative 2 is a 0 of multiplicity 2 because I have 2 as an exponent here. So I'm going to write those. These are for zeros. And 5 is a 0 of, multiplicity 1. Okay, so there's number 4. Now let's take a look at step 5. So step 5 says, for the fraction of the denominator, note that the multiplicity is of 0 to determine the local behavior for those factors not common to the numerator. Find the vertical asymptotes. So we need to find the vertical asymptotes for step 5. All right, so now the way that works is, it's where my bottom is 0. Now keep in mind here, my zx to begin with had to be in reduced form or simplified form. So if I had an x minus 5 down here, those would have to cancel out, and that's called like reducing. We don't have to worry about that here. That's fine. It's already done. So what we have to get for this one then is we got to find those vertical asymptotes. So those vertical asymptotes are going to be x equals 3. Now remember, that's an equation of a vertical line. It's not solving an equation. X equals negative 1 and x equals negative 4. Now again, it's what makes the bottom 0. And that's what we end up with for those vertical asymptotes once it's reduced as a whole. And that just simply means if we have a factor on top, it cancels with the factor on the bottom if they're the same. All right, now step 6 now. Okay. 6 says factor the denominator common to the factor in the numerator. Find the removable discontinuities by setting those factors equal to 0 and then solve. Now we don't have any removable discontinuities. If we did, that simply means that, hey, I might have an x plus 2 on the bottom and then cancel. That's what a removable discontinuity would be. But we don't have any here, so just going to check box. Okay, 7, compare the degree of the numerator and the denominator to determine the horizontal or slant asymptote. So now for step 7, we have to find the asymptotes. The horizontal or oblique asymptotes. So I'll write this. Horizontal or oblique asymptotes. Okay, so let's find out what we have, if we have one. So now if I look at the degree on the top, if I multiply it out, it would be degree 3. If I multiply the bottom out, it would be degree 3. So since the degree is the same on the top and the bottom, that tells me I just have to find the leading coefficient of both the top and the bottom because the degree is the same. So if I just multiplied, really what I have on top is x plus 2 times x plus 2 times x minus 5. So if I just took the leading coefficient, it would be x cubed. And if I just took the first term of the bottom, it would also be x cubed. So we really get x cubed over x cubed. And as x gets sufficiently large, like 100,000 over 100,000 is still 1, I'm going to get a 1 here. So this tells me I have a horizontal asymptote at y equals 1. And there it is. So now step 8 says we can graph it. So that's what we're going to do now. We're going to graph this thing. I'm going to write this over to the other side here, though, so I have the room. All right, so now we're just going to put all of our information in here together. So the Y-intercept is 0 5/3, so that's 0 almost 2. So if you notice, I put all of these notches are 2 apart. So just before 2. Then I have the X-Intercepts, and those are here. That's -2, 0, and 5, 0. So that would be here. Oops, let me fix that. And 5, 0, 2, 4, and 5. So it's going to be in the middle there. Okay, so those are those 3 points. And then we have here the zeros, -2. The -2 is multiplicity 2, so that simply means we bounce off. Okay, the vertical asymptotes are at x equals 3, -1, and -4. So I'm going to put those in. So at 3, that's right here. So those are the asymptotes. This one's x equals -1. This one over here is x equals 3. And this one on the other side is x equals -4. So those are 3 asymptotes there. And I tried to do dotted lines there so you could see that. So now we have to talk about the horizontal or oblique asymptotes. We also have one at y equals 1. There's the horizontal asymptote. Now this looks terrible. I wish I would have zoomed in more on this one. I should have did every one. That might have been a little bit nicer as far as all of these points are concerned. At least I think here. So anyways, let's complete this then. And we'll need some more points to try to understand what's happening here. Now I do see one thing on the right side here. Now I can't cross the x-axis again. So there's going to be a line right under here. And it's going to follow, and then this is going to go straight. Now it can't be straight down, so I should have did a half at a time. So this is going to approach this vertical asymptote here. And this is going to approach this horizontal asymptote. Not too shabby I did there. I should have maybe used a different color. Hopefully you can see that okay. And now the middle, notice here, this is just above it. So, and again, I can't cross the y-axis again either. So what's going on here is I have this piece. Let me see if I can fit it between the two. This is going to go between them. It's going to hit here. And this is going to have to possibly, well, hang on, let's wait. Well, no, it has to go up because we don't have another, what do you call it? We don't have another X-Intercept. So we only have the 2. So we can't cross it again. Now, if you look at the asymptote, where's it at? -2 is of multiplicity 2. So that tells me the one at -2 is going to bounce off. So that makes perfect sense now. Because there's nowhere for it to go. Because once I get to it, oops, darn it. I'm going to do a half at a time. This is difficult to try to fit all this in there. And, oops. It's going to come around here. And I'm going to get closer and closer to that horizontal asymptote. So there's that. Now keep in mind here that we can't be in, let's say, this section up here and also this section down here, because then it wouldn't be a function. So it's either going to be above it or below it, and with these horizontal and vertical asymptotes. On occasion they'll cross, but there has to be a X-intercept to make you think about that. So anyways, so now let's look at the left side here. So this is 2, 4. So after 4, -4 I should say, we're going to have to either be up here or down there. So what I'll do is I'll just plug in 5 into this thing. and that gives us 0. So when I plug in 5 here, that's going to be a 0 there. So I'm going to end up with 0 over some number. So that tells me that negative 5 is what I'm supposed to plug in. 5 zeros here. So that's okay, we already have that one. But negative 5 now. So negative 5 plus 2 squared, negative 5 minus 5 over negative 5 minus 3, negative 5, what is that? Plus 1, and then negative 5 plus 4. And this here is going to be 3, so that's going to be 9, and that's going to be times negative 10. That's 90, negative 90, excuse me. And then this is going to be negative 8 times negative 4 times negative 1. So that's 32 positive, so negative 32 on the bottom, negative 90 on top. So that's going to end up being positive 90 over 32. So 90 over 32 is almost 3. So that tells me at 5, which negative 5 would be here, it tells me that I'm going to be about 3, so I'm going to be up here. Close to the 3. So about there. So that gives me everything else I'm going to need now, because it tells me where I'm going to end with this one. That'll be here. Oh, these are terrible to graph. They're horribly, a lot of information. So there's our completed graph. There's everything we'll need for this. Got all of our intercepts, and we should label those intercepts and stuff. So keep that in mind too. I labeled all my horizontal and vertical asymptotes, and I should label those points too. So that would be 5, 0. There's my other one here. Negative 2, 0. And my y-intercept there, which is 0, 5 over 3. So I guess that'll be enough for this one here. So that's my graph. So I'm not sure if that made it any easier to see the actual graph itself, but hopefully it does. And the purple are just the asymptotes. So anyways, that's our graph for this one here. It takes quite a while to get all this information together, but there we go.